Automatic medians calculation. Let's see how to perform automatic medians calculation and the correction for tobacco, weight, and other factors with SsdwLab 6. First of all, we go, as usual, to the menu tools and we select the sub-menu, Automatic Calculations, and then the option, Calculation of Medians and Regression Coefficients. We can observe a screen where on his left side there are a set of controls. We can define the screening profile from which we will select the data. Which marker we are going to use. In this case we choose free beta-chorionic gonadotropin. There are some intervals that appear automatically. And then we define what kind of equation we want to be presented with the data of medians calculations. We select an exponential equation with two coefficients. Also we can choose which interval of time we want. Of course we can select all the interval of time in which the screening profile has been active. Or we can select only part of the cases. We select all cases validated or not, but only single gestation. Also we can classify by a set of filters: smoking, race, diabetes, and finally we execute our query. We can observe that the results are presented on the right side of the screen. We can see the results in a graphic, but also they are presented in numeric form. On the top of the screen are shown the two coefficients that represent this equation. We can see a green line that represents the new equation, and the gray line represents the previous equation, and in this table, we can see the number of samples in each interval of days or week, the value obtained for the medians, and the value obtained from the regression. And now we define a three coefficients equation instead of two. On the top right of the screen, we can see the value of the three coefficients. We can note that the determination coefficient is a little bit higher, but not enough good as we want. Now we are going to try to increase the number of equations coefficients. In general, it gives us more perfect equations that fit better to the medians calculation that performs their program. The valuation of the equation is done by the coefficient of determination. So the determination coefficient has increased from 0.94 to 0.98, which means that it's more correct. Here, we can see the number of determinations, the curve, in green the new one, and in gray the previous curve. We can perform the medians calculation for pregnancy-associated plasma protein A. In this case are usually used polynomial functions with two or three coefficients, without exponential transformation, and we leave the other parameters as they were. When we execute the query, we can observe that the program presents a curve. This polynomial function represents the medians in the different week intervals where papa is measured. On the top of the screen, we can see the value of the two coefficients of the equation. The determination coefficient is very good. 0.94 for papa in general is better than beta. Also we can observe the number of determinations, the medians calculated, and the medians obtained from the regression. The green line represents the new obtained equation, and the gray line the equation that we were using. But this equation is incorrect because we can observe negative values of the median regression. And in the graph the curve cannot adopt values lower than 0, so we should do another equation. We can try to increase the number of coefficients, and we will see that the regression function with its determination coefficient of 0.99 is better. And this equation does not have values lower than 0. So we would choose this equation for pregnancy-associated plasma protein A. This submenu can be also used for calculate the regression function for nuchal translucency. Generally, is used the one obtained by nuclides with more than 100,000 cases. For nuchal translucency, we will not use days or weeks, we will use biometrics, specifically CRL. We will define an equation with power of 10 transformation, which is the used by nuclides in their computations, with three coefficients. and we see that the curve we get is very similar to its publications, which were made some years ago. Here we see that the nuchal translucency ranges from 1.1 to almost 2. In an interval of 44 to 82 mm length of the fetus. At the top of the screen, the table shows the data. Naturally, these data can be exported, we can generate a PDF, etc. Calculation of maternal weight correction. Now let's see how to perform the calculation of their correction for maternal weight. Therefore, how we compute the equation that serves to correct the maternal weight. Since maternal weight affects marker's blood concentration, we go as usual to the Tools menu, and would choose the appropriate option. We select the suitable profile, the marker from which we calculate this equation, in this example the PAPA. Also we define the time interval. It is advisable to have at least 1,000 determinations for these calculations are reliable. We take both validated and not validated. We choose single fetus pregnancies. Also we have the option to filter by race, diabetes, smoking, etc. We execute the query, and we can observe on the right side of the screen that the results are presented in tabular form, and in a graph representing the equation that allows us to correct for maternal weight. We will see at the top a table with the weight ranges and the median of multiple of the median for each weight range. We can observe that non-corrected median MOM, in the penultimate column, varies greatly, whereas when the correction is done, which is represented by the curve again in green, the median of the MOM obtained is almost 1, in all weight ranges. Also the more or less broken lines of the graph indicate the gray is the previous curve that was used, and the green line, their values are close to 1, except in the intervals of high weight. The equation in this case is a Nevu-type equation with reciprocal correction. They may also consider other types of functions that are available, but these are the most common. The correction method Nevu is reciprocal transformation. Now we are going to do the same for the free beta instead of PAPA. And the data are presented on the screen. These data are presented in a table on the top of the screen, where we can see the weight intervals, the number of determination for each interval, the medians obtained directly and the medians obtained applying the transformation. And we see that this is a Nevu-type function with reciprocal transformation, which will present automatically on the screen. And obviously we can generate a file that allows us to export these data in PDF mode, or in other formats. Calculation of the smoking correction. And finally we will see how to calculate the correction factors. Specifically in this case we will evaluate the correction for the mother's smoking habit. We go to the Tools menu and we select this submenu. We define the screening profile from which we get the data, the marker that we want to value, free beta-chorionic gonadotropin, and the type of correction factor to be analyzed, the time interval in which we will analyze all this data, the type of gestation, only single pregnancies, for obvious reasons, and we generate the query. The results are presented in the screen. In this case there is no graph. We can observe the correction factor calculated MOM, and if the difference between the patients that present this correction factor and the patients without the correction factor is statistically significant. So if we should value it or not, for example in this case, we can see that correction factor calculated MOM is very small, and that the difference is not statistically significant. If we chose another correction factor such as Moroccan, and we analyze it for beta and for PAPA, we can see that for beta, the correction factor is very small and not statistically significant. Whereas if we analyze it for pregnancy-associated plasma protein A, the correction factor is statistically significant. Therefore this correction must be made in pregnants that are Moroccan. Here we can see that the difference is statistically significant, with a really small p. And that's all related to the automatic calculations.